And they asked you what the prefix poly was. What does poly mean? Several or many? Yeah. So poly, in this case, is a many-sided. One book uses shape, one book uses figure. So whatever you'd like. A polygon is a many-sided shape. So then you got to think about this. So if I give you 3 toothpicks on your desk, can you make a shape out of 3 toothpicks? And you'd all make the shape of what? A triangle. If I give you 4, you'd make a square, and 5 and so forth. But if I gave you 2, could you make a shape? No, you would just end up with a V, wouldn't you? Or maybe a T or an L, but you couldn't close it. So we have to have some more definitions with the polygons. It has to be a closed shape. In other words, you can't just sort of leave out connection. You can't have an opening. And if we go back to those 2 toothpicks, the minimum number of sides we can have is 3. Because you can't make a shape with the 2 toothpicks, but you can with 3, you can with 4, you can with 5. And if you look over here, this poster does it well. You've got 3 sides, 4 sides, 5, 6, 7, and it goes up to 16. The more sides that you have, the shape ends up looking more like a what? Circle. But it can't be a circle because the circle doesn't have sides. Does that make sense? But this stops at 16. Could they have gone to 32? 92? 222? Yeah, so what's our maximum? If our minimum is 3. Yeah. Our maximum is going to be infinity. And let's just put in parentheses, it's going to looks like a circle. But it certainly is not end up going to be a circle. There will still be very detailed sides. Okay, what else do we know about a polygon? Anything else? Okay, I'll add each. Oop, I just spelled each wrong. Each side is a segment. And the last thing that you might not know is that the segments cannot cross each other. So let's go to your white sheet and look at number 1. Do you think that arrow is yes a polygon or no a polygon? Yes. I think it is. Yeah. I think each side is segment. I think it's closed. Each side is a segment for sure, and the sides don't cross each other. How about number 2? No. That's a great example of the sides crossing each other. So number 2 in that first blank would be no. How about number 3? I think 3. Okay, and our last part is number 4. What do you think about number 4? We have one more definition to add. What's wrong with 4? It's got a curve. So, oops. No curves whatsoever. And that goes along with every side has to be segments too. Okay, in the next section, we have to answer is our polygon convex or concave? So here is an example of a 4-sided convex shape. And then here is an example of a 4-sided concave shape. So what do you think the definition is going to be for convex or concave? Lauren, what do you want?
Convex is like go down.
Yep. Yep.
It's like concave, there's like an indent somewhere.
An indentation somewhere?
Yeah.
Yeah, I like that. The shape goes inside. I like that. I really like that. Someone in the last class said it looks like it caves in. So let me tell you the book's formal definition. Each of these sides is a segment. Do you remember that from over here? And from chapter 1, a line is made up of multiple segments, agree? So if you take each segment and make a line out of them, and since this has 4 sides, we would have 4 lines. If each side segment is extended into a line, do any of the lines go into the interior of the shape? And this is definitely no. But for the concave one, if I just do even the second side right here and I extend it into the line goes into the interior of the shape, and so that's the formal definition of concave. So are you ready? Formal definition of concave. If the segments are extended into lines, the lines go into the inside of the polygon. But I like Lauren's better. I can remember it. If it goes inside or it caves in, then you know the shape is concave. Book's formal definition, take any one of those sides, a segment, extend it as a line, and if the lines go into the interior or the inside of the polygon, then it is concave. So now go back to that worksheet, the white one. You have the second line there underneath number 1, because now we have to answer this, is the shape convex or is the shape concave? So that arrow, what do you think, everybody, for number 1? Is that convex or concave? Concave, absolutely concave. Okay, now number 2 is not a polygon, so we don't really have to worry about it. Let's go to number 3. Extend those sides, like you could actually draw on it, or you can visually do it, and you don't have to do it. If you extend any or all of those sides, do any of them go into the interior?
Yes.
And so that would be concave. Absolutely. And then 4 is no, we don't do it again. Okay, so now go back to your notebook. Draw me a 6-sided figure that is concave and a 6-sided figure that is convex. Draw a 6-sided polygon that's concave and a 6-sided figure that's convex. Who's going up and doing it? I got a new purple marker. Come on. Yes. 6. You can go anywhere you want. Or you can change color if you don't want to. Yeah, you're fine. Beautiful. She did a great job. Convex and concave. How do yours look? Ooh, that's a good concave one, isn't it? Ooh. Concave, to me, is the easiest one to draw. Because as long as you go in. Good. Can you draw convex, too? Okay, now let me ask you, can you draw a 6-sided regular polygon? Can you draw a 6-sided regular? Okay, that's like pulling back all the way to semester 1. A 6-sided regular, anybody know it? Can you go up and draw it? No, come on, really? Semester 1's already gone out of your head? Gone, never coming back? Okay. Are you gonna do it again?
Yeah.
I'm a hero. If I said, oh, I have a blow pop.
It's okay, I don't need one.
Who said they don't need it? Oh, almost my hero. If you're cape on, you just need your whole outfit. That was really good. There is a blow pop in the first cabinet.
It's okay.
Oh. Okay. All right, so regular. What's the definition of regular? All sides equal, equilateral and equal angular. And probably because someone is just lazy, they don't want to do equilateral and equal angular, then you go, holy cow. They just call it regular. Now, let me ask you this. If a shape is regular, I don't care if it's a pentagon, octagon, whatever that is, if it's regular, is it convex or concave all the time? What do you think? It's going to be convex all the time. So a regular shape is always going to be convex. A regular shape is always going to be convex. What's regular again? Equilateral and equal angular. Okay, let's see how good you are with names. Now let's go to your purple or your green sheet, whatever color you got. Let's do the first column going down. First column going down. How many sides does a triangle have? And everyone's going to say? 3. How about quadrilateral? 4. Pentagon? 5. Hexagon? 6. Hepta? 7. Octagon? 8. Decagon? 10. Oh. Dodecagon? No. 12. 12. Okay, so what's missing in there? 9. On the bottom somewhere? Nonagon is 9. Underneath the chart, just add it so you have his name. And I believe we're also missing 11. Hendecagon, 11. And some of the posters, like this one goes up to 16. And some of them have up for a few more. But what happens if you go back to that 22-sided figure, or the 222-sided figure, or the 300-sided figure? They got lazy. So after 12, most books just do this. 13-agon. So that just means it has how many sides? 13. Or 67 means it has 67 sides. So that last column on the purple sheet says n-gon. So that just means it has n sides. So you have to know up to 12. From 3 to 12, you got to know those names, okay? Most of them easy. Probably just not 9 and maybe 11. Okay. But the rest I think you did pretty well on. Okay. So now let's start and let's draw a pentagon in our notes. I'm drawing him convex. I labeled them A, B, C, D, and E for the vertices. And the next vocab word they want to make sure you know is the word diagonal. And a diagonal is a segment drawn from a vertex point to another, and here's the big word, to another non-consecutive vertex. So what's non-consecutive? What's non-consecutive? Okay, let me ask you this. If I tell you the number is 12, what's the next consecutive number? 13. Okay, so if I'm non-consecutive, I'm not next door. So if I'm looking at vertex E, my consecutive neighbor would be D or A. My non-consecutive would be B or C. So a diagonal is a segment from a vertex to another non-consecutive vertex point. So if we just randomly pick this vertex E, I can only draw a diagonal from E to B and then E to C. I can't draw one from E to D or E to A because those are the next consecutive vertice points. Our whole goal in this section is to know that in this original pentagon, there are 5 sides and 5 interior angles. Agree? And the interior angles, no matter how you draw it, convex or concave, does not matter, that the angles will always add to a certain number every single time. So this worksheet, purple or green, whatever you have, will help us derive how they get to that answer, okay? So the first thing is they're going to ask us, how many diagonals can you draw from one vertice point? So this is a 5-sided figure, and I can draw 2 diagonals. Okay, let's next to it draw a quadrilateral. A, B, C, D. If I randomly choose vertex B, how many diagonals can I draw just from vertex B? 1 to who?
D.
That was really good. 1 to D. So look at 4 sides, 1 diagonal. Anybody see a pattern already? What do you see? 3 less. Okay, so you just take the number of sides and subtract 3. So we're going to go down the second column. Are you ready on your sheet? If I have 3 sides in a triangle and I subtract 3, what's my first number going to be? 0. And if you think about it, if you've got a triangle, I can't draw from this vertex anywhere that is not non-consecutive. So 0 for the first number in the second column. What would quadrilateral be? 1. Pentagon is 2. Hexagon is? Hepta is? 4. Octagon is? Good. Decagon? 7. Dodecagon? Okay, now the formula. The formula is you take the number of sides and what do? So the formula, n minus 3. Very nicely done. So 0, 1, 2, 3, 4, 5, 7, 9, and n minus 3. Now look, by putting these diagonals in, they thought it was pretty cool because what shape was formed when I put the diagonals in? A triangle. And you learn from the first semester that every triangle has 3 interior angles and that the sum of the 3 interior angles will always add up to what? 180. Well, first let's count the triangles. So in a 5-sided figure, I end up with 1, 2, 3 triangles. In a 4-sided figure, how many triangles? 2 triangles. So what's the formula, do you think, this time? N minus 2. You got it. Okay, so let's go down for the number of triangles formed. Would be 1 for the triangle, 2 for the quad, 3 for the pentagon. What's the hexagon? 4, Heptagon is 5. Octagon is 6. Deca is 8. Dodeca is 10. And the formula is n minus 2. Very nice. Now remember, our goal is to find the measures of all the angles in the inside. So can you imagine if like 32 sides, you'd have to have 32 angles? No one's going to want to measure all that every single time. So they come up with these formulas. Now look, if I divided the pentagon into 3 triangles, don't you know from semester 1 that these angles add to 180, these angles add to 180, and these angles add to 180 because they're 3 triangles. And so therefore, 180 plus 180 plus 180 is 540. Okay? Look at the quadrilateral. You have 2 triangles, right? This triangle is how many degrees? And this one is 180 and 180 is? That means every single time, these 4 angles will always add to 360. So let's go down for the sum of the measures of the interior angles. Sound good? First one's easy. What's the first one? 180. In a quadrilateral, what'd we just say? 360, because you have 2 180s. Yep. A pentagon is 540 degrees. A hexagon is 720 degrees. A heptagon is 900. An octagon is 1080, so 1080 degrees. Don't forget your degree bubble. The decagon is 1440 degrees. The dodecagon is 1800 degrees. 1800. Now here's the hard part, the formula. I have to count how many triangles I have, do you agree? And then simply multiply it by what? 180. So what's the formula for how many triangles I have is, n minus 2. So then you multiply it by 180. So here is your sum of your interior, your first huge formula. First one, sum of the interior angles. Sum of the interior. So if you have 69 sides, you're going to take 69 minus 2 and get 67 times 180. That's how many degrees if you added all 69 angles up. Okay, now look at the next column on that chart. I think the title starts off by saying if, what's the word? Regular. That word I would circle, I would star, draw an arrow to, draw a mean face by, something, because now the shape has to be regular. Well, think about that. If I have 4 angles that add to 360 degrees, and if I'm now regular, which you beautifully knew was equiangular, equilateral, right? If all the angles are the same, what would you do with my total 360 to get each of these if they have to all be the same? Divide by? Excellent. And if this was a total of 540, and I wanted to know what each of them were, because they're all the same, you would take the 540 and divide it by 5, which is the number of sides. Okay, so going down, 60 degrees for the triangle, 90 for the quadrilateral, 108 degrees for the pentagon, 120 for the hexagon. The heptagon is a decimal. It's 128.57. 128.57. The octagon is 135. The decagon is 144. The dodecagon is 150. Now somebody tell me what I do to the formula. Each. Excellent. Excellent. And you can put it in brackets. You don't have to. I actually like how you said to put it in brackets so you know to do the whole top and then divide it by n. This is fantastic. Each interior angle. But put an asterisk. We have to be regular. We have to be regular. Because they all have to be the same. So your formula is n minus 2 in quantity times 180, all divided by n. That was fantastic. Okay, can we go back to your notes? Let's do 2 problems really quick. Great ACT, SAT problems. Find the sum of the interior angles of a 32 polygon. Find the sum of the interior. Does this problem tell you at all that it's regular? Yes or no? No. So this is just the sum of the interior. So just the sum of the interior formula is a simple n minus 2 times 180. So what goes in for the n? How many sides it has, right? So what goes in? 32. So you take 32 minus 2 times the 180, and you should get how many degrees? 5,400. Excellent. And don't forget your degree symbol. It wants the sum. So that means if you could actually draw, I could never draw a 32-sided polygon, could you? I can't even draw the 16. Okay? So if you can draw 32 sides and you mark all 32 angles, they're always going to add up to 5,400. Now, what if the problem changes and they want each interior angle of a regular 32-sided polygon? What you need to do is you need to take that sum that we just found and divide it by the number of angles, which is the same as the number of sides. So you just told me that the sum was 5,400. And since it says it's regular, every single one is going to be the same. What am I dividing it by? 32. So go ahead and take 5,400. Do we have a decimal? 168.75? Yeah. Each. Do you see the language between the total and then each interior? Sound good? Yeah.
Will the problems we do always be regular right now? Because how would you figure out if it wasn't regular?
You're just going to figure out the sum. You wouldn't figure out each. Does that make sense?
Yeah.
Yeah. Not until we get a little further. Okay, so I'm just going to stop right here. Does that sound good? Then tomorrow we'll start with the exterior, and then we'll do a worksheet tomorrow. Sound fabulous?